Hi, my name is Vincent, and today I want to take a look at some AP Calculus AB multiple choice questions, no calculator. So for the first question, we have find the limit as x goes to infinity, and we have this expression here. Now, the way to attack this problem is we only need to consider the leading terms of the numerator and denominator. And we could do this because this is a limit as x goes to infinity, and we have a rational function, a polynomial numerator and denominator. So if we look at the leading term, we'll get the leading term by multiplying 2x times negative x, which would give us negative 2x squared. And in the denominator, the leading term would be generated by multiplying x times x, which would give us x squared. So to evaluate this limit at infinity, we just need to look at the coefficients because the exponents of the highest term match. So we'll have negative 2 over 1, and this limit works out to negative 2, giving us choice B. For the next question here, don't fall victim to the trap of treating this as a natural log. Even though it's a fraction, you want to rewrite this as x to the negative 2 dx. That way you could use power rule. So then we apply power rule. Negative 2 plus 1 is negative 1. Divide by negative 1 makes this negative. And then we just write plus c. And that's going to give us choice D for question 2. For question 3, we need to use product rule. So we could start off, we don't want to multiply this out. That would take you a ton of time. So we're going to do the derivative of x minus 1 is 1. And we're multiplying that by x squared plus 2 to the third power. And then for the second part, we're going to have plus x minus 1 times, and to take the derivative of the next term, we need to use chain rule. So we're going to have 3 times x squared plus 2 to the second power. So we're just applying chain rule to the exponent 3 here. So we do the power rule, and the derivative of the inside, x squared plus 2, is 2x. But you'll notice this does not match any of the answer choices. So what we need to do next is we need to simplify this by factoring out a greatest common factor. So the greatest common factor between both of these is going to be x squared plus 2 to the second power. So if we factor out x squared plus 2 to the second, on the first term, we're going to have left x squared plus 2 to the first power. So we'll write a bracket, and we're going to have x squared plus 2 to the first times 1. So we don't need to write times 1. And then on the second term, we're going to have the x minus 1, the 3 in front here, and the 2x. So then we just need to simplify this doing the algebra. And if we simplify this, we're going to have x squared plus 2 to the second power. And we'll have x squared plus 2 plus, and think of this as 6x. If we distribute 6x, you're going to have 6x squared minus 6x. So then all we need to do is combine like terms, and we're done here. We're going to have x squared plus 2 squared times, and if we do 6x squared plus x squared, that's 7x squared. We'll have a minus 6x and a plus 2. So for question 3, this is going to match choice D. Okay, for the next question here, technically we can do a U substitution, but the function inside sine and cosine is just 2x. So when you have an easy function like 2x, the shortcut to avoid U substitution is to divide by the derivative of the inside function. So if I want to take the antiderivative of sine 2x, I would have negative 1/2 cosine 2x. And the way we're doing this quick is we're saying the antiderivative of sine is negative cosine, and then we divide by the derivative of 2x, so we'll get the 1/2 in front. And we'll repeat the process for the second term. The antiderivative of cosine is sine. And we write the 2x, and then the derivative of 2x is 2, so we divide by 2 to get the 1/2 in front. And then we have plus c here. So for question 4, this will work out to choice B. And just know, if you're ever unsure, you could always take the derivative of your answer choices to show that they don't work. Like right away, let's say choice C. If we took the derivative of the second term, you'd have 2 cosine 2x times 2, which would give you 4 cosine 2x, which would not match the coefficient in the integral here. So that's how we know something like choice C is out. Okay, for question 5, the first thing you should always do with limits is try to plug in. But when we try to plug in here, this is going to work out to 0 over 0, which is indeterminate. So we're going to apply L'Hopital's rule. So to apply L'Hopital's rule, we're going to take the derivative of the numerator and denominator. And we're going to get 20x to the third plus 16x over 12x to the third minus, and that should work out to 32x. It's a little sloppy there, but that's a 32. Okay, so at this step, if we try to plug in 0 again, we're still going to get 0 over 0, which is indeterminate. So we're going to apply L'Hopital's rule once more. And if we apply L'Hopital's rule again, we're going to get 60x squared plus 16 over, and we'll do 12 times 3 is 36. We'll have x to the second, and then minus 32 for the derivative of negative 32x. But now when we plug in 0, the first terms are going to cancel in the numerator and denominator, and we'll be left with 16 over negative 32, which reduces to negative 1 over 2. So for question 5, we should get choice A. Okay, for the next question here, we have a piecewise function, and we're trying to evaluate which of the following statements are true. So when you have a piecewise function and you want to find the limit, the key is they're going to give you something factorable, and then you're going to cancel the common factors and then plug in the value, in this case 2. So if we find the limit as x approaches 2 of our function f of x, we're going to take the part with the fraction, and you'll notice it's a difference of 2 squares. And we could break this down as to x plus 2, x minus 2. So the limit of f of x as x approaches 2, if we simplify this, we just plug in now is 2 plus 2. That's going to give us 4. Remember, if we try to plug in 2 right away, we're going to get 0 over 0. So when our limit is indeterminate, we can use factoring to find the limit. But what that tells us, our limit does exist. Our limit is equal to 4. So 1 is true. Is the function continuous at 2? Well, if we look at what is the function value at 2, the second line here tells us the function value at 2 is equal to 1. And since 4 does not equal 1, that means the function is not continuous at x equals 2. All right, if this number down here was a 4, then we could say that the limit, that the function is continuous at 2. But here's the thing, if we know the function is not continuous at 2, that automatically disqualifies it to being differentiable at 2. So by getting rid of Roman numeral 2, we also get rid of Roman numeral 3. And that means that only 1 is true. So for question 6, we should have choice A. Okay, for question 7, we have a particle moving along an x-axis, and we're given the velocity function. And we want to find what is the position of the particle at t equals 1. And they're telling us the particle is at position 2 at time 0. So if we say x of t is the position function, they just told us that at time 0, which means x of 0, the particle is at position 2. And we're trying to find out what is x of 1. Okay, this is the part we don't know. But they gave us a velocity function. And if we take the integral of velocity, that's going to tell us our position function. Okay, but the strategy here is we'll make the limits go from 0 to 1. Because just know the antiderivative of velocity is position. So if we apply the fundamental theorem of calculus part 1, this is going to equal the position at 1 minus the position at 0. Okay, so all we're doing is we're writing the velocity function in our integrand, and we use this concept of the fundamental theorem of calculus, and we could say that this is equal to x of 1 minus x of 0. Now the left-hand side, we just treat normally. We're going to do the antiderivative, which will give us t to the third plus 3t squared, and this is going from 1 to 0. And on the right-hand side, we have x of 1 minus, and x of 0 we solved, was given to us, that's equal to 2. So then the left-hand side we could evaluate just by plugging in. This is going to be 1 plus 3 minus 0, and this is equal to x of 1. minus 2. So on the left-hand side, we're going to have 4, and that's equal to x of 1 minus 2, which tells us the position at 1, if we just add 2 to both sides, is equal to 6. So for question 7, we should have choice B. Okay, for the next question here, we're going to take the derivative and we're going to plug in pi over 9. So we're going to use chain rule to find the derivative. We're going to have negative sine 3x times the derivative of the inside is 3. So if we work this out and we get this this expression here, the last thing we need to do is just plug in pi over 9. So if we plug in pi over 9, we have negative sine. And then if we multiply pi over 9 times 3, that's going to give us pi over 3. And then this is times 3. Now just know, this is very important. Don't get tripped up at this step. You want to think of on the side sine of 60 degrees. And sine of 60 degrees is equal to radical 3 over 2. So this is going to give us negative radical 3 over 2 times 3, which is going to give us choice E, negative 3 radical 3 over 2 after we simplify everything. Okay, for the next question here, there's a few ways you could break this down. The easiest way is you start ruling out the answer choices. And if you look, g of negative 2, if I have the integral from negative 2 to negative 2, that's equal to 0. So if we're trying to find out which of the following values is greatest, 0 is probably going to be out of the mix here. Same thing if we look at choice A. If we're going from negative 2 to negative 3, negative 2 is our starting point. So if I find the area between negative 2 and negative 3, and I'm not going left to right, I'm going right to left, this is going to give me a negative value. So I could probably rule out choice A when we start considering the others. And notice g of 0 is telling us to find the area under the curve from negative 2 to 0 if we use the definition of g here. And that's going to give us this trapezoid here. So because this is positive, this answer choice C is a contender as one of the greatest. But then if we look, g of 1 is the area from negative 2 to 1, which would take this blue trapezoid and it would extend it all the way here and include this triangle. So since choice D includes another shape that also has positive area, it's going to be greater than the area described in choice C. So this one's out. And if we look at choice E, g of 2, that's going to extend this shape all the way to this section here. And yes, technically it is adding more area, but since the area is under the x-axis, we have to treat it as negative. So that would eliminate choice E, and the correct answer would be choice D here. The other way of breaking this down is to use fundamental theorem of calculus part 2. If you want to find a maximum value of a function, you take the derivative, which the derivative of g is going to equal f of x by fundamental theorem of calculus part 2. And if we look for a sign change in g prime, the only sign change that occurs at 1, and it's a sign change from positive to negative. So if this is the only critical value on our interval and it's the site of a local maximum, then that would also make it an absolute maximum because it is the only critical value. So that's using more theory of why the answer to choice 9 is letter D. Okay, now this question here, for question 10, we have the graph of the function f shown from 0 to 3. And we want to know which of these has the least value. So choice A represents the full area under the curve. So if we look at the full area under the curve here, it's this section here. And now for choice B, we're looking at a left Riemann sum with 4 subintervals of equal length. So if we break this into 4 equal parts here, a left Riemann sum is automatically going to be greater than the area under the curve because it's going over. This function is decreasing, so the left Riemann sum is going to go over, so this one is definitely not the least. Now a right Riemann sum, if we look, is going to go under the curve here like this. So that eliminates choice A because the right Riemann sum, one of these rectangles, is going to go under the curve, which means its area is going to be less than the actual area. Now the midpoint Riemann sum we could eliminate as well, because that's going to be between the left and the right. If we use a midpoint value here, like let's say we look on this interval here where we drew the right rectangle, if we look at the midpoint rectangle, it's going to go above the right one. So that one's out as well. And it's the same concept when we're talking about the trapezoidal sum, that if we look at a right Riemann sum, if we were to connect these two and make a trapezoid, this trapezoid here is going to have greater area than this rectangle on the inside. So choice E is out, and the correct answer is going to be choice C. Okay, for this question here, we have the graph of a function f is shown above, and we want to know which of the following could be the graph of f prime, the derivative of f. So the key here is we want to describe the behavior of the derivative because we don't have an actual function to take the derivative of. And if you look at f, f is increasing, and then it decreases, and then it increases again. And if a function is increasing, that means the derivative is positive. When it decreases, that means the derivative is negative. And once again, when it increases, the derivative or slope is positive. So we need an answer choice that goes positive, negative, positive. A and B both do that, so we could eliminate the other choices, C, D, and E, because this one here goes positive, negative, positive, negative. It has like that extra negative there, so C is out. D goes negative, positive, negative, which doesn't match what we have here. And E is always negative, so we could get rid of choice E. But to be accurate for choices A and B, we have to look at exactly where the function changes from increasing to decreasing and from decreasing to increasing. And if we were to mark A and B respectively in the answer choices for both choices A and B, you'll notice that we're going to go with choice B here because at A and at B, the sign of the derivative is going to change. And notice here we're going from positive to negative at A, and at the location B here, we're going from negative to positive. So choice B is the one, whereas choice A is shifted over a little bit, so we could get rid of this choice. Okay, for question 12, we have f of x equals e to the 2 over x, and we want to find the derivative f prime. So to find the derivative, we have f prime of x equals, and since it's e to a power, we have e to the, and we rewrite this as 2 over x. But then the derivative of 2 over x we have to multiply by. And just know that 2 over x you could think of as 2x to the negative 1. So the derivative of 2x to the negative 1 would be negative 2x to the negative 2, which we could also express as negative 2 over x squared. So for this question here, we absolutely need to be comfortable doing the chain rule. So if we simplify this, f prime of x equals, and we'll have negative 2 over x squared times e to the 2 over x. So the answer to this question is choice D. Okay, for the next question here, this one is testing your ability to use chain rule. So when we look at the derivative of f of natural log x, this is going to give us f prime natural log x times 1 over x. Okay, so all we did here was just apply the chain rule because we have a composition of functions. But the next thing that we need to do here is we need to use the definition of f of x that they gave us. So if f of x is equal to x squared plus 2x, then f prime of x is equal to 2x plus 2. So then to evaluate this expression that we have here, we're going to have, instead of f prime natural log x, now we could just plug natural log x into the derivative that we just found on the line above. So we'll have 2 times natural log x plus 2, that's just this component here being transferred over. And then this is all being multiplied by 1 over x. So if we simplify this a bit, this is going to be 2 natural log x plus 2, and this is all over x. So 13 is going to work out to choice A. So for this example here, you need to know the composition definition of the chain rule, and then you need to be able to compose the function with the derivative f prime here to get this correct. Okay, for question 14, we have a polynomial function f has selected values of its second derivative f double prime given above, and we want to know which of the following statements must be true. So when we look at this, if we are talking about f is increasing on the interval from 0 to 2, or f is decreasing, the only thing that tells us about if a function is increasing or decreasing would be the derivative, f prime, not f double prime. So a and b don't necessarily have to be true. Now we also have f has a local maximum at x equals 1, and the confusion that people might run into here is they're looking for a sign change from positive to negative at one of the zeros, but this applies to the derivative once again. Okay, this would be if we were applying the first derivative test. So the second derivative test would not necessarily guarantee that there's a local maximum in this case here. So now when you narrow it down to choices D and E, you might get a little confused here, and if you don't read carefully, choice D is a very tempting answer choice because students might look at this and say, all right, f double prime, and they look at this and they say at 1, I have a sign change from positive to negative. But we cannot guarantee that this is necessarily going to happen at x equals 1. And what we mean by this is for choice D, suppose that f double prime of 1.1 were to equal, let's say, 3. Okay, then what that tells us is that there is no sign change at x equals 1 for our second derivative. You know, like we could also have something along the lines of this, like f double prime of 1.5 is equal to 0, and then it changes signs from positive to negative. So we can't guarantee that there's going to be a point of inflection at x equals 1 because there are a lot of x values missing between 1 and 2 to guarantee the sign change from positive to negative. But choice E definitely has to be true because if we look at the interval from 0 to 2, we have positive values and we have negative values. And based on the intermediate value theorem, since this is a polynomial function, it's continuous. To get from 5 to -7, we have to pass through all the values in between. So we're going to have some positive values and some negative values, which means there is going to be a sign change in concavity because f double prime will change from positive to negative. But be careful of choice D. It is a very tempting answer choice, but it is a trap. Okay, for question 15, we need to use a u substitution. So if we let u equal x squared minus 4, then we'll have du equals 2x dx. And what we could do from here is we could solve for x dx because that's the numerator term we're going to replace. And we'll get 1/2 times du equals x dx. So now when we rewrite our integral, the integral x dx is 1/2 du, and in the denominator x squared minus 4 is equal to u. So now this is just 1/2 natural log, absolute value of u, plus c. Now we plug in. We'll have 1/2 natural log absolute value x squared minus 4 plus c. So for question 15, this will match choice C. Okay, for the next question here, we need to use implicit differentiation. We have sine of x times y equals x. So anytime you have a function with x's and y's, you can have x's and y's in your derivative as well. So to take the derivative here, the derivative of the left side, we're going to have cosine of x times y times, and we have to take the derivative of the inside. We need to use chain rule. But to take the derivative of x times y, we have to use product rule, and the derivative of x is 1, and we have times y, plus x, and the derivative of y we're going to call dy dx because we're taking the derivative with respect to x in this question. Okay, and then don't forget, a lot of people will somehow like mix this step up. Don't forget to take the derivative of the right-hand side, and the derivative of x is equal to 1. So one thing we can do here is distribute cosine of x times y, and we'll have y cosine xy plus x cosine xy times dy dx, and this is equal to 1. So what we need to do here is we need to get the non-dy dx terms over to the other side, and then we divide to solve this out. So we're going to have x cosine of xy dy dx equals, and we're going to subtract the y cosine xy. We have 1 minus y cosine xy on the right side now. And then to solve for dy dx, we're just going to divide by x cosine xy. So this tells us that dy dx equals, and we have 1 minus y cosine xy, all divided by x cosine xy. So for this question here, this is going to match choice D. Now for the next question, we have the graph of a function f shown above, and we have horizontal tangents at x equals 2 and x equals 5. So we can mark this off here. Horizontal tangents means zero slope. And they're saying let g be the function defined by g of x equals the integral from 0 to x of f of t dt. And for what values of x does the graph of g have a point of inflection? Now, you should never assume things in math, but most of the time that they give you an area function where your integral has your independent variable x as one of the limits, chances are you're going to have to do FTC part 2, the fundamental theorem of calculus. So when we take the derivative of g, the derivative of the right side, the integral and the derivative cancel, and it turns the integrand into f of x. So this is usually a pivotal step when solving a problem involving an area function, that you have to remember FTC part 2. So this is a very important theorem that will definitely show up. And you want to know, for what values of x does g have a point of inflection? So anytime you also hear point of inflection, that means we're looking for a sign change in the second derivative. So the second derivative, g double prime, would equal f prime of x. So to find a sign chart for g double prime, we need to look for the slope of f. So this sign chart, we could also call it f prime. And the hint they gave us here was that the graph of f has horizontal tangents at x equals 2 and x equals 5. So what this tells us is that f prime of 2 and f prime of 5 are both equal, and they're equal to 0. So when we make our sign chart here, we can mark this at 2 and 5. So then to talk about the slope of f, we just look between 0 and 2, the slope is positive. So that tells us that the sign chart here between 0 and 2 is positive. And between 2 and 5, the graph is decreasing. So the slope of f, or f prime, is negative, which makes g double prime also negative since they're equal. And then from 5 to 6, we notice here that the slope goes positive again. So that means f prime is positive. And since f prime and g double prime are equal, then we could also label the g double prime sign chart positive as well. So there are two sign changes, and they occur at x equals 2 and x equals 5. So the answer to 17 is going to be choice C. Okay, for this question here, we have in the xy plane, the line x plus y equals k, where k is constant, is tangent to the graph of y equals x squared plus 3x plus 1. So if they're telling us that this line is tangent to this curve here, then we want to think of that line as y equals negative x plus k. Now the reason why we want to rearrange it in y equals form is because it tells us the slope of the line. So remember, this here represents our slope. The slope of our line is negative 1. But how do we find slope in calculus? We find the derivative of our function. So that means we're going to set the derivative equal to negative 1, and we'll be able to solve for our values to find k. So we find the derivative of the curve, and we'll get 2x plus 3. We're just applying power rule to this function here. But if the slope of the tangent line is negative 1, then that means to find the x value where this happens, we're going to set this derivative equal to negative 1. So we get 2x plus 3 equals negative 1, which will give us 2x equals negative 4 if we subtract 3 from both sides. And this implies that x equals negative 2. But to find out the value of k, we also need to know what is the y value here. So we plug in the x value into our original equation to solve for y. So we'll have at x equals 2, y equals negative 2 squared plus 3 times negative 2 plus 1. So that tells us y in this case is 4 minus 6 plus 1. And if we have 4 minus 6 plus 1, negative 2 plus 1 is negative 1. So then all we have to do to solve for k is plug in for x and y. Remember, we have x plus y equals k. So in this case here, we're going to have negative 2 plus negative 1 equals k. And this is going to give us k equals negative 3. So for 18, we should have choice A. Okay, for the next question here, we need to find the horizontal asymptotes of the graph. So to find horizontal asymptotes, you need to look at the limit as x goes to infinity or negative infinity of the function. So if we start off, we'll start with the easier one. The limit as x goes to negative infinity of 5 plus 2 to the x power over 1 minus 2 to the x power. Well, if we look at x going to negative infinity, just think, as x goes to negative infinity, this is going to give us a very small number here. Like, just imagine, like, this is going to go on in your head. Like, this is you during the test. And think of a number like towards negative infinity. Even if we did like negative 100, this would equal 1 over 2 to the positive 100. And 1 over 2 to the positive 100. As we increase this number, as it goes towards negative infinity, our quotient is going to shrink to 0. So that tells us here, since 2 to the x shrinks to 0 as x goes to negative infinity, we're going to have 5 plus 0 over 1 minus 0, which is equal to 5. So the trick is, as x goes to plus or minus infinity, just think of a number like 100 or negative 100 and see how it affects the expression like 2 to the x. And that'll help you see if it shrinks to 0. So that means 5 is going to be one of the horizontal asymptotes, which means A is out, B is out, D is out. So right away, let's say you don't know how to do the positive infinity side. Narrowing it down to these two choices gives you a 50-50 shot of getting this correct. But to find the limit as x goes to positive infinity, the problem with this example now is we can't just use mental math to reason this out, because this is going to give us the form infinity over negative infinity, which is indeterminate. But we could apply L'Hopital's rule here, because indeterminate form, when your limit is an indeterminate form, you can apply L'Hopital's rule. So we take the derivative of the numerator. The derivative of 5 is 0, and the derivative of 2 to the x is 2 to the x natural log 2. And in the denominator, the derivative of 1 is 0, and then we have minus the derivative of 2 to the x is still 2 to the x natural log 2. Now everything cancels algebraically, and you'll have 1 divided by negative 1, which is negative 1. So it is choice E, because y equals negative 1 is also a horizontal asymptote for the graph of y equals. Okay, for question 20 here, we have a function with the second derivative given here in factored form. And we want to know, what are the x-coordinates of the point of inflection of the graph of f? Now, the most common mistake I would say with this question here is people look at this and they say, oh, I remember, you have to find the zeros of the second derivative. And if we look at the factored form, the first factor, x squared, gives us a root of 0. X minus 3 gives us a root of 3. And x minus 6 gives us a root of 6. And people look at this and they'll assume that this is going to have a sign change all the way through, and they'll choose choice E. But you absolutely have to check the sign change here. So if we look, and a shortcut is x squared is always positive when, x squared is always positive unless at the site of a 0. So this first factor, we don't really need to check because it's x to the second, which is always positive. So when we do plug in numbers, doing this like with mental math, we really just have to check the other two factors. So let's say we plug in negative 1. If we plug in negative 1, we'll have negative 4 times negative 7, which we don't care about the value, even though it's positive 28. We only care about the sign. So now pick an easy number between 0 and 3, like 1. And remember, we only have to check the last two factors because the first one is always positive. We'll have 1 minus 3 is negative 2. 1 minus 6 is negative 5. And this is still positive here. So if we plug in 1, we're going to have a negative times a negative still being positive. If we plug in a number like 4, 4 minus 3 is 1. 4 minus 6 is negative 2, and 1 times negative 2 is negative. So we could label this interval here negative. And then for the last interval, let's say we plug in 7, we'll have 4, because we'll have 7 minus 3 times 1, which is positive 4. So the reason why we had a check is, notice at 0, there is no sign change. So this one is out. Okay, this is not going to be the site of a point of inflection, but there is a sign change at 3 and 6. So we can say that at x equals 3 and x equals 6, we do have a point of inflection. So for 20, we should get choice D here. Okay, for this question here, we have a particle moving along a straight line, and we have the graph of the position function for values of t between 0 and 6. And they tell us the graph has horizontal tangents at t equals 1 and at t equals 5. And we also know that there's a point of inflection at t equals 2. So maybe we'll have to make use of some of this information in a moment, so it's good to label it on the graph. And they're asking for what values of t is the velocity of the particle increasing. Well, remember, how do we look for where velocity increases? To find out where velocity is increasing, that's one way of saying that it's accelerating. And in particular, if the velocity is increasing, that means acceleration is positive. So what we need to do is we need to use the graph of position and look for where is acceleration positive. But just know, how do we get from position to acceleration? Well, basically what we're looking for in the graph is where is the second derivative of position positive. And another way of translating this to a graph is where is the graph concave up. So to identify where a graph is concave up, you're just looking for the portion of the graph that's in the shape of a U. And if we look, that's all the way in this region here up until the point of inflection. They told us that there's a point of inflection when t is equal to 2. And this is where the graph begins to take the upside down U shape. So from 2 to 6, the graph is concave down, but from 0 to 2, it's in the U shape, so the graph is concave up. So that's our interval. From 0 to 2, x of t is concave up, which means the second derivative, or acceleration, is positive, which is where the velocity would be, or I'm sorry, when the velocity would be increasing. So just know t equals 1 and t equals 5 is like a bit of a trap. Like they gave you extra information that we didn't need. We only needed to know where the graph was concave up in this question here. So for question 22, this is a bit wordy, but we have a lot of variables, and it's representing a rumor spreads among a population of n people, and the rate that it spreads is proportional to the product of the number of people who have heard the rumor and the number of people who have not heard the rumor. And we have, if P denotes the number of people who have heard the rumor, which of the following differential equations could be used to model this situation with respect to time t, where k is a positive constant. Now, I read this multiple times. Like, this is a question that I left out and came back to because it was a bit confusing. But when they say proportional, they're referring to a direct proportion, which is in the form y equals a constant k times x. But the confusing part here is they're saying that the rate is proportional. And remember, the rate that the rumor spreads is based on the change in the number of people who have heard the rumor over the change in time. And the number of people who have heard the rumor is represented by P. And if you look at every answer choice, this part here, dP over dt, represents the rate that the rumor is spreading. So they're saying that this rate is proportional, so times k, and x is going to represent the second part here. The product, we'll say, is x. So the product of the number of people who have heard the rumor and the number of people who have heard the rumor is going to be represented by P based on what they told us. And the product of the number of people who have heard the rumor and the number of people who have not heard the rumor. So we have to think the number of people who have not heard the rumor would be represented by capital N minus P, because they told us capital N is the total number of people and P is the number of people who have heard the rumor. So N minus P represents the people the number of people who haven't heard the rumor. So when they say the product of the people who have heard the rumor and the number of people who have not heard the rumor, we're doing P times N minus P, and we're just using the formula for a direct proportion. And for question 22, what we have here matches up to choice B. Okay, for this question here, we have a separable differential equation with an initial condition. So the first thing we could do is cross multiply to get the y term with the dy and to get the x squared term with the dx. And now that the variables are separated, we could take the antiderivative of both sides, and we'll have 1/2 y squared equals 1/3 x to the third plus the constant c. So now we make use of the initial condition, but be careful. This represents the initial x and the initial y. This notation could be a little confusing, but it's kind of like function notation, but with a y as the function's definition here. So if we plug in -2 for y, we're going to have 1/2 -2 squared equals 1/3 times 3 to the third power plus c. And it's going to give us half of 4, which is 2, equals 9 plus c, which implies that c is equal to 2 minus 9, or -7. So now we plug into our general solution, which is in this line here, and we're going to have 1/2 y squared equals 1/3 x to the third, and then we have -7. So for this part here, we'll just move this down a bit. For this part here, to solve for y, we're going to multiply both sides by 2. So the next phase of this problem, we're going to have y squared equals, and if we double everything, we're going to have 1/3 times 2 is 2/3 x to the third minus 14. And now we're going to take the square root of both sides. But guys, this part here, it narrows it down to the last two choices. Please do not fall victim to this trap. If you just assume it's going to be positive, you're going to get this wrong. You have to be very careful. And in this case here, we're going to go with the negative root. Now, the reason why we're going with the negative solution here is because the initial condition, the y value, is -2. So remember, the last thing you should do before you choose your answer to a differential equation is you must make sure that the initial condition checks out. So just know, if we did have to check, if we checked our work, if you plug in x equals 3 to our answer, we're going to have negative square root, and we'll have 2/3 3 to the third minus 14, which gives you 18 minus 14, which is negative square root 4, which is -2, which matches the initial y value. But if you go with choice D, it's assuming that the initial y value was +2. So be careful at that step. It would be sad if you did all this great work and then you make a minor mistake like that at the end. Okay, for question 24, we have a function that's twice differentiable. We're given f of 2, f prime of 2, f double prime of 2. And we want to know the value of the approximation of f of 1.9 using the line tangent to the graph of f at x equals 2. So whenever I do problems like this, I think of the equation of a line is in the form of y minus y1 equals m times x minus x1. And to write the equation of a line, you need a point and you need a slope. But just know here they told us the point to write the equation of our line. Our point they gave us was 2, 1. This is like our x1, y1. And to find our slope, we're going to use our derivative. So our slope here is equal to f prime of 2, which is equal to 4. So now we write the equation of the line. We're going to have y minus 1 equals 4 times x minus 2. And if we work this out, y equals 4 times x minus 2 plus 1. So to use our tangent line to approximate f at 1.9, now all we do is plug in. So f of 1.9 is approximately equal to, and we use the line that we made here, we'll have 4 times 1.9 minus 2, and then plus 1. So the approximation, we're going to get 4 times -0.1, which is -0.4, plus 1, and minus 0.4 plus 1 is equal to 0.6. So for 24, we should have choice B. Okay, this question here for 25, we have a function defined above. It's a piecewise function. We have c and d are constants, and we want to know if f is differentiable at x equals 2, what is the value of c plus d? So if we're assuming f is differentiable at 2, that means it's continuous at 2 and the limit exists at 2. So what that tells us is the left side derivative at 2 is going to equal the right side derivative at 2. So the work that we show here, if we take the derivative of f, the derivative of cx plus d, if they're constants, is just c. And on the right side, the derivative of x squared minus cx is going to be 2x minus c. But it's differentiable at 2, so now we plug in. So if we plug in 2, we could set these equal to each other. So all we did was set the left derivative equal to the right derivative, and we could set them equal when x is 2 because we assume that f is differentiable at 2. And when we work this equation out, we're going to have 2c, after we add c to both sides, is equal to 4, which tells us c is equal to 2. So the next thing we should do here, since f is differentiable at 2, this also means that f is continuous at x equals 2. And if it's continuous at x equals 2, well, that means that the limit exists at 2, and the left limit is equal to the right limit at 2. So what we could do now is we're going to plug in for what we just found for c. So f of x is now 2x plus d for x less than or equal to 2. And we have x squared minus 2x for x greater than 2. So we could set the left side equal to the right side when x is equal to 2. So the left side, we would have 2 times, instead of x, we're plugging in 2 plus d equals 2 squared minus 2 times 2. The right side is going to give us 0, and the left side is going to give us 4 plus d, which tells us d is equal to negative 4. But remember, they're not asking us to solve for c or d. They want us to find the value of c plus d. So c plus d, if we do 2 plus negative 4, is negative 2, which works out to choice B. For the next question here, we want to know the slope of the line tangent to y equals arctan 4x at the point at which x is equal to 1/4. So anytime you hear the phrase line tangent, that's telling us we need to find a derivative. So the derivative of arctan of 4x, we're going to have 1 over 1 plus the inside squared. We're basically going to have to use chain rule here. So we have 1 over 1 plus the quantity 4x to the second times the derivative of 4x is equal to 4. So this is going to give us 4 over 1 plus 16x squared. Don't forget to square the 4 with the x. So then we want to plug in 1/4. So y prime when x equals a fourth is equal to 4 over 1 plus 16. And if we square 1/4, 1/4 times 1/4 is 1/16. So this is going to give us, these will cancel, 4 over 1 plus 1, and 4 divided by 2 is equal to 2. So 26 is choice A. Okay, for the next question here, we have a slope field, and we want to know which of the following, what is this a slope field for? Which of the following differential equations? So the trick with this problem is to look for a pattern. And if you'll notice here, when x is equal to negative 1, if x equals negative 1, the derivative for that whole column, dy dx, or y prime is equal to 0. And also, this horizontal section here, when y is equal to 0, that's also telling us that the derivative y prime is equal to 0 as well. So we want to look through the answer choices and see if we plug in negative 1 for x or y for 0, will the derivative always be 0? And if we look at this one, A, we could eliminate, because if we plug in negative 1 for x, if y is anything else but 0, then the derivative is non-zero. So A is out. For choice B, what I would do is factor out y. And if we factor out y, we're going to get x minus 1. And notice here, if we plug in negative 1 for x, this will give us negative 2 times y, which is not always going to be 0 if y is anything but 0. So for choice B, if x is negative 1, the derivative is not always 0, which we need to be the case based on this pattern. For choice C, if we factor this, we'll have y times x plus 1. And notice here, this is going to be the answer, because if x is equal to negative 1, this factor equals 0, which makes the whole derivative, or y prime, equal to 0. And if y is equal to 0, the second factor is equal to 0, which makes the entire derivative equal to 0. The problem with choice D is that if we factor out x, This will tell us that when y is -1, the derivative is always 0, and when x is 0, the derivative is always 0. And for choice E, this is true that when x is -1, the derivative is always 0. But if y is equal to 0, this is not necessarily equal to 0, dy dx. So that's why choice E is out for this question. Okay, for the last question here, we're given the function f, which is a differentiable function, and we're given a few values of f, and we're also given a few values of f prime. And then next we're told that the function g is differentiable, and g of x is equal to f inverse of x for all x. And we want to know what is the value of g prime of 3. So to know the value of g prime of 3, we need the formula for the derivative of an inverse function. And if you forgot that formula, it's very easy to forget. Then the way to remember it is to use the definition of an inverse function with chain rule. And if f and g are inverse functions, based on this assumption here, then f of g of x is equal to x. So if we take the derivative of both sides, on the left side we would use chain rule, which would give us f prime g of x times g prime of x. And on the right-hand side, the derivative of x is equal to 1. So then the formula for the derivative of g is going to equal 1 over f prime of g of x. So for this question, we want to find what is g prime of 3. Tells us, using the formula, we need to find 1 over f prime of g of 3. So for this example here, the new question becomes, what is g of 3? And to find g of 3, we're going to make use of this function value here, f of 6 is equal to 3. Because if we think about the concept of an inverse function, if f of 6 is equal to 3, then if we apply the inverse function to both sides, the inverse function being g, then that'll give us g of f of 6 is equal to g of 3. And on the left side, g and f are inverses, so they cancel. See, g of x is equal to f inverse of x, which is going to give us 6 equals g of 3. So now we can make this substitution here, and we'll have 1 over f prime, and instead of g of 3, we're going to replace the inside with 6. So then this last part here, to evaluate the derivative of the inverse, we need to know what is f prime of 6, which was also given to us. F prime of 6 is -2. So this works out to 1 over -2, which will give us choice A, -1/2. Okay, well, this is going to conclude this multiple choice section. If you found this video helpful, please click like and subscribe below, and thanks for watching.